Next, let us talk about the general notes to be inserted on the drawing of the water reticulation plan to be submitted to the water supply agencies. You may refer to the Appendix 2 of the guideline for the submissions of water supply and internal plumbing system for development schemes. Kindly note that this guideline is applicable for the water supply agency like Laku Management Sdn Bhd and Cebu Water Board. Now, if you are submitting to the other water supply agency, you shall refer to their respective guidelines. The requirements may vary slightly, but I believe the principles are more or less the same. For learning purpose, I'm going to point out a few important points to encourage the understanding. Now, if you wish to know more, you can go through the guideline yourself, or you may refer to the guideline given by the water supply agencies of your areas. First, all pipes and fittings have their own requirements. They need to comply with certain standards or specifications. They are HDPE pipes and also ductile iron pipes. This will have to comply with the relevant standards. These are HDPE pipes and these are ductile iron pipes. All the sluice valves shall be double flank with the specifications as listed here. Double flank sluice valve looks something like this. The meaning of double flank is to have these two flanks available to be joined with the water mains. By looking at the diagram here, the center part is the sluice valve, this part is the water main, and this part is another water main. Sluice valve used to connect two water mains, and it acts as a gate controlling the flow of waters in the water mains. When the sluice valve is closed, waters is not allowed to flow. When it is open, the water can flow from the water mains. The working pressures for the sluice valve shall be 16 bars. You will need to strategically locate the sluice valve in order to minimize the water supply interruptions during the pipe breakage and maintenance. The installations of the sluice valve underneath the road pavement or concrete footpath should be avoided. It is so that for easy access of the sluice valve when maintenance is required. The pillar hydrant should be of the standards and requirements conforming to this. There may be underground fire hydrant, but it should be conform to this standard. All fitting should be flank ductile iron. These are examples of the fittings. It is basically used to join the water mains. Sometimes you will need to change the course of directions of the water mains. For example, this fitting, changing the directions of water mains by 90 degrees. Sometimes you need an additional outlet, or when you are joining the water mains with different connection system, then this fitting is used. There are two main types of connection system here. One is push-in joint, another one is flank joint. The flank joint involves the bolt and nut system, where there is a circular plate attached to the end of the water mains. This is to be connected with the flank of another water mains during connections. The flanks allow for the installations of the bolt and nut system, joining the two water mains. As for the push-in joint, it comes in a couple. For each watermass, one end will be the head, another end will be the tail. Later, when it comes to the connections, the tail will be inserted into the head, and there is an interlocking mechanism between the head and tail to ensure the connections between the two watermass. Next, all data iron pipes and fittings which are installed underground shall be wrapped with polyethylene sleeve. This is to prevent the direct contact with the ductile iron pipes as a protection from corrosions. It looks something like this. Now, if you are using the HDPE pipes, joining the HDPE pipes can be done by these two mechanisms. We have butt welding of HDPE pipe joints and electrofusion machines and coupler. If you wish to know more about this butt welding, you may refer to their YouTube. Basically, it uses machines for positionings of the HDPE pipe, and there will be trimming of the surface of the pipe so that the joint can be properly joined during butt welding. You may also search the internet related to the electrofusion machines and coupler. Next, the HDPE pipe stud ends shall be long collar and shall be joined with HDPE using electrofusion couplers. Butt fusions of end studs shall not be allowed. Long collar stud end shall be factory produced. These are the stud ends. This is used to connect pipes together. You have an interlock with the flange so that when come to joining of the pipes, flange may be used. The long collar here is to be joined with the pipes using the electrofusion coupler. Butt fusions is not allowed. All underground flange shall be wrapped with approved anti-corrosion wrappers. The purpose here is to prevent corrosions of the flanges. Concrete truss blocks shall be provided at all bands and tees. What are the truss blocks? It looks something like this. When there is a band or tees, you will need a truss block to hold the tees and bands in positions, creating the reactions to the force generated by the water due to sudden change in the directions at the tees and the junctions. You know that the water pressures in the water mains is relatively high. There won't be any issues when the water is flowing straight. However, when it comes to a change of the directions, this high water pressure will generate a force which is large enough to cause movements of the piping system, as well as the concentrated stress that can eventually fail the entire water reticulation systems. Therefore, you will need something to generate resistance to this force, and that is the functions of the truss blocks. Depending on the layout of the pipes, the locations and the design of the truss block varies. Normally, we use the truss block in the mode of compressions, as concrete is good in the compressions. For example, this. Assuming the water is flowing here, when come to the bank here, the water is forced to go in these directions. The changing of the directions can result in a force acting in these directions. Now you will need this truss block to generate resistance. Having the force generated by the water and the resistance provided by the truss block, now this truss block here is undergoing compressions. Same principles goes with this, and also this, and also this. Now in the case that the compressive truss block is not able to be provided, if you are putting the truss block at the other side, the forces generated by the water can have the piping system moving away from the truss block. Then you will need some mechanism to pull the joints of the pipes in order to keep the piping system in static conditions. For example, something like this, something like this. The truss blocks shall be placed on the fittings in the directions of the water flow. Do not encase the entire fittings in concrete. This is probably meant for future maintenance. To make it simple, concrete truss blocks shall be provided at all bends and tees. It restrains or anchors placed up against the underground pipe fittings in order to prevent the movement of the underground pipes from the truss force in water mains. Next, all culvert or drain crossing shall be installed over the top level of the culvert or drain, and there should be an air valve at the highest point. If possible, the pipe crossing over the culvert shall be installed outside the culvert wing wall, and the crossing shall be installed such that it will not obstruct footpath and the like. Let's say now you need a pipe crossing the culvert. You should not go underneath it, neither you should go through the culvert. Going underneath it makes it difficult for maintenance. Going through the culvert will have issue with the structural integrity with the culvert. Now the only way it will be go above the culvert. Now whenever possible, the pipe cross over the culvert on top of the wing wall. This is the wing wall. Having the pipes going on top of the culvert, there will be a change of the elevations, which can look something like this, where you have a culvert underneath it. In this case, there may be issues with the accumulations of the air bubbles at the highest point of the pipe. Therefore, you will need an air valve to help to release the air bubble, so that the air bubbles do not disturb the flow of water in the water mains.